This is Dr. Sirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss our question bank on trees, binary trees and graphs. Let's have a look at what a nonlinear data structure is first of all. So a nonlinear data structure is a structure where data is related to more than one data elements, right? So the basic examples for that is a tree and a graph. If you look at a tree parent node can be related to more than one node, right? And its children can be like this. And coming to graphs, right? So in exam point of view, my dears, they might be asking you what a nonlinear data structure is. How is it different from linear data structure? The basic difference is the word itself, linear and non-linear, right? And that is the data is stored in a linear manner. For example, in array, even though the data is stored in consecutive memory locations, and in case of linked list, they are not stored in contiguous memory locations. But the advantage is, or the main point of crux is, every element is related to only one element next to it, right? Coming to nonlinear data structure, one node is connected to more than one neighbor. It may have more than one neighbor for it, right? That is a nonlinear data structure. So, and you can mention the different types of things that you have under linear and non-linear, represent them and give ADTs of that, abstract data types of all, then the answer is done, right? As I said, the basic difference. So how the data is organized is the basic difference between linear and non-linear data structures. Coming to the concept of trees, if they ask you what a tree is, start mentioning that it is a non-linear data structure. Please guys, when you are asked a question, please confine your answer to the subject or discipline in which you are answering it, right? So, and the abstract model of it is a hierarchical structure, a top-down model, you can say. And the best example is file systems, any environment where there is a hierarchy, right? So that will be the basic applications of trees. Yes, the basic terminologies which you are going to have in trees there. So questions may come like, they might give you a tree and ask you what are the descendants of a certain node, who are all the siblings of a certain parent, right? And these type of questions. So for that, you need to understand the basic terminologies of tree. So the root over here is A, and siblings are of same parent, right? So B, C, D becomes the siblings, right? So coming to one more example of siblings, E and F are siblings, G and H are siblings, but F and G are not siblings. Why? Because they do not share the same parent. Okay. Coming to internal node, a node which have at least one child is internal node. The blue ones which I have shown, A, B, C and F, all the four are internal nodes, whereas external nodes are E, I, K. The nodes which do not have any children, also known as leaf nodes, are external nodes. Okay, ancestors mean parent, grandparent, grandparent, all comes under ancestor zone. Coming to descendants zone, child, grandchild, grandchild, all becomes the descendants. So think logically when someone asks you a question, guys. Okay, depth of any node is the length or path from the root till that node. For example, what is the depth of node F? From the root you have to start. So how we are going to reach F? So via B only you have to reach. So how many edges you have crossed? 2. So the depth of F is 2. Okay. So these are the few terms you might get in your exam. Yes, height. What is the height of a node? From the root, so from that node to its deepest leaf. depth you are going to calculate from the root, whereas the height you are going to take leaves as consideration. What is the height of, say, B? So height of B will be to its deepest leaf, even though E is also a leaf of subtree B, but the deepest one will be either I, J or K. So how many edges you share? 2. So the height of B is 2. Okay, so if someone asks you what is the height of the tree, then from the root till its deepest leaf you are going to calculate. So how to reach the deepest leaf? Via B, F and K. So 3. So the height of this tree is 3. Okay, then uh, degree. Degree is the number of children it has. For any node, degrees will be in 2 types, my dear. Degree of a node and degree of a tree as a whole, right? So degree of a node is the number of children it has. For example, for F it is 3, for B it is 2, right? For and degree of the tree is the total number of that is the number of children the root node have, which is 3, is degree of the tree. Coming to the concept of subtree. So have a look at this one, the violet one which I have mentioned over here. It is nothing but a subtree which is headed by C. Subtree is nothing but a subset of node and its children is nothing but a subtree of a given tree. Okay, even you can say F is a subtree. This is a subtree which is headed by F. That is, F is acting as a root of the given subtree and its children are I, J and K. Okay, these are few terminologies which you will encounter for 1 marks. And what is a binary tree? An extension of a tree is a binary tree. Whenever someone asks you what is a binary tree, please start your definition with the word. It is a non-linear data structure. Please do not forget that point, guys. It is a non-linear data structure where a constraint is imposed on nodes saying that they can have a maximum of 2 children only. Such a tree is known as binary tree. Have a look at this one. Every node have a max of 2 children only, right? So the next one, what are the variants of binary tree? So these are the 5 variants of binary tree. Guys, very important question in exam point of view. So what is a full binary tree? A full binary tree is a tree which says that every node can have either 0 children or 2 children. That is, they have barred the uh, condition saying that they can have 1 child, right? What they have said, a binary tree can have a maximum of 2 children. That is, it can have either 0, 1 or 2. If you revoke the point of 1, then you are left with 0 and 2. It is nothing but a full or strictly binary tree. Have a look at the tree which I have given. Here every node have either 0 or 2 children. So with that you can conclude that the number of internal nodes is equal to 1 more than the number of children, right? The number of internal nodes uh, plus 1, add 1 to the number of internal nodes, you'll get the number of external nodes. You can go with any example, guys. Guess one important point is if they ask you about the variance, please mention it with an example. Don't write a statement and leave it as it is. Please draw a tree, explain it. Just one line explanation will suffice the answer, right? So please draw a tree and explain it. Coming to complete binary tree. So a complete binary tree is also a binary tree where all the levels are filled except the last, and the last level is filled from the left as far as possible. Okay, that is, have a look at this one. 8 is at level 0. 4 and 10 are at level 1. And 2, 6, 9 are at level 2. Well and good, right? So now the thing is, Have a look at the nodes, how they are filled from level 1. Level 0, it is full. Level 1, as far as possible, full. Coming to level 2, all the elements are filled from left to right. Am I right? Left to right. Once level 2 is fully filled, then go to level 3, start filling that too from left to right. So such a tree is known as complete binary tree. And it goes with the depth of the tree with a number of nodes is 2 to the power of d plus 1 minus 1, and the number of leaf nodes is 2 to the power of d. Okay, so this is a complete binary tree. Then comes perfect binary tree. The perfect binary tree is a tree where internal nodes have 2 children and all the leaves are at same level. Right? Have a look at this picture. All the internal nodes. What are all the internal nodes you have? 8, 4 and 10. Every internal node must have 2 children and all the leaf nodes must be at the same level. Okay, so this is a perfect binary tree. Coming to next, balanced binary trees. Balanced binary trees rely on balance factor. Balance factor is nothing but the difference between the height of left subtree and the right subtree. And for each and every node, the balance factor can be either -1, 0 or 1. If it is other than these three values, we call it as an imbalanced one. So this is also known as height balanced trees also. These balanced binary trees, you may get the question in either way, height balanced or just balanced binary trees. Please mention about balance factor. It is a keyword which addresses this question. Okay. Next one, left skewed and right skewed binary trees. Left skewed is if all the nodes are on the left side, you do not have a single right child also, it is left skewed. Coming to the right skewed, all the elements are inserted on the right subtree, you do not have even a single left child, is nothing but a right skewed. These are the two different versions. For example, if you are given if your binary tree is converted into binary search tree and you are trying to insert an ascending order data or descending order data, you will get left skewed and right skewed respectively. Okay, so next one, binary tree representation. This is one of the important questions which you encounter in your question banks, my dear. How to represent binary trees? We can represent them using arrays as well as linked list. At times they will straight away ask you what is a sequential representation of binary trees, or they may ask you linked list representation of binary trees. But if they generalize the question saying that explain binary tree representation, you have to address both. One is using arrays and the other using linked list. Let's have a look at both of them. If you are asked for sequence, that is array representation, always remember that sequential representation is nothing but in a sequence, means arrays they are talking about. Okay, so always the root will have an index value 0 and its children from left to right will bear the index values. So, and its grandchildren from left to right. So 3. If 4 have a right child, it will have the index 4. If 10 have a left child, it will have index 5. And here is the 6. So the maximum size required is 7. 0 to 6 index values, the total size is 7. So that is one of the drawbacks of sequential. Before itself, you need to know what is the height of the tree. That is from the root till its deepest leaf. If you know the height, then based upon the height, you will be having a maximum of 2 to the power of d plus 1 minus 1 number of cells in your one-dimensional array. Few may go in waste. For example, the index value 4 and 5 went into waste because 4 is not having any right child, whereas 10 is not having any left child. But in the future, if they have that child, where they are going to place. So to overcome those chaos, they have placed an empty space. If the tree is sparse in nature, these empty spaces will be huge, which is a memory loss, wastage of memory. That is the basic disadvantage. Advantage will be direct access. That is the basic advantage when you work with arrays. It provides you random access, right? It provides you random access and it is quite easy to work with. Very good. But it suffers memory. Wastage of memory will be more. So to overcome that, you can work with lists. That is linked list more precisely. Or if I refine my answer, it will be double linked list. Because in double linked list, each node will have three parts. The middle part will be data, left part will be the left node's address, and the right part will be right node's address. Right? The right child's address, if I place it more precisely. So using double linked list, you can go for the representation. Right? So the advantage is you need not know the height. So whenever the height increases, you dynamically increment the, you dynamically create a node and build the relations. No problem. Wastage of memory will be there. That is one of the disadvantages. Okay, and insertions and deletions are easy without a much effort we can do, and without affecting the other nodes we can do, just like the removal of the elements in a double linked list, which we have learned, right? That will be, this will be easy. That is a basic advantage. That is a prerequisite of knowing the height is not required, and next insertions and deletions are easy. But memory wastage is there because you are using double linked list, two addresses you are storing with every node, that will be a wastage. So the next one, binary tree traversal. How to traversal? This is one of the most important questions in your question bank, my dear. Go through that. Many questions are given on that. So what is a binary tree traversal? Traversal is nothing but running from one node to the other node to covering all the nodes, right? So that is tree traversal. In arrays, for example, you take array, linear data structure. How you are going to traverse? You have the index values, one after the other, you are going to hop. If it is a linked list, even that, even here also, every node will have the address of the next node, so you will have hop in a linear fashion. But coming to non-linear, how you are going to hop? You have one option in the left, the other option on the right. What to choose? So there are three different fashions to do the same. So the first of its kind is inorder traversal. In inorder traversal, go towards left first, root, and then right. So they'll ask you mostly for a given tree, try the inorder traversal or an algorithm for the same, right? So let's have a look at an example. If this is the tree, start from the root, go towards left, the end, till the end. Okay, so you have reached 2, which is the leftmost one. So as it is not having any right, take the root and right is not there. Go to the root, 4, then 6, then 8, then go towards right, 9, 10, 11 is the inorder traversal. The next one, pre-order traversal, where preference will be given to the root first, then left and right. So root first, 8, next 4, next 2, then go to the right side, 6, go to the right of 8, 10, then 9, then 11. So this is the pre-order traversal of the given tree. Coming to the post one, root will be sent to the last, left, right, and root. Okay, so start from the root. So 4, 2, 2 will be inserted first, then the right 6, then the root, which is 4. So 2, 6, 4. Now left part is done, go to the right of 8. So 9, 11, 10, 8 is the answer. Okay, this is the post order traversal. So previously what we have done is binary tree was given as input, and you have to get the traversal. You have to write the traversal list. But the question can be in reverse also. Many questions are there in your question bank based upon this one, my dears. So that is you will be given with a pre-order and in-order, a combination, right? Pre-order in-order or post-order in-order. You have to construct a binary tree out of it, right? So in this one, remember that in-order is used to identify the left and right subtrees, whereas pre-order or post-order will be used to identify the root. Okay, so initially pre-order, we all know that pre-order is starts from printing the root. So start with the G. Okay, so G is the root. Identify where G is in your in order. Break the list into two halves, the one left and the one which is right. Right. What is the next element in pre-order? B. Where is it in order? Here it is. The left of it is Q, the right of it is K, C, F, A, but do not touch G because G is already taken, which is the root of the tree. Right? So, next, go to the next element in pre-order, which is Q. So, you do not have any left elements of Q. Right elements B is there, but B is already taken as the parent of Q. So, we cannot touch it. So, Q is a leaf node. Similarly, A. Left of A is KCF. B is the parent of A, so do not touch it. Coming to the right of A is G, which is its grandparent. A's grandparent is G, so do not touch it. If the relation is already built, do not touch it. If the relation is not built, then make them. So KCF. So A's children are KCF, but who is the right? Which one is the left? We do not know. So as in the in order, K, C, F are on the left side of A. So place all the three on the left side of A. Okay. Next element is C. Coming to C, the left of C is K and the right of C is F. Represent the same. Coming to the next element, K. K's left is B, which is K's grandparent, and right is C, which is his parent. So we cannot touch them. They are already related to K. Next element is F. E for F, the left is C, which is his parent, and A, grandparent. So we cannot touch them. Next element is P. Coming to P, where is P in order? Have a look. Here it is. And G. For P, G is its parent. We cannot touch it. And all the remaining are on the right side. So place it on the right side. But precisely we cannot say out of E, D, H, R, who will be its child, grandchild, grandchild, and so on. Yet to be decided. Right? So I have placed all as cumulatively as the family of P. Then next element in pre-order is D. So now D is going to break the list. So in order, the left of D is E. So Pakka E is the left side. Coming to P. P is the parent of D. So I cannot touch it. Coming to the right hand side of D, H and R. Right? So H and R, they are nowhere related to D yet. They are related, we know that, but how, we do not know. The precise relation we do not know. So I have placed them cumulatively as the family of D. Next element is E. The left element of E is P, which is his grandparent. Right is D, which is his parent. So I cannot touch. Next is element R. Coming to the element R, its left child is H. You cannot consider D because D is the parent of R. On right side of R, there is no element. So R do not have any right child. Next is H. Coming to H in order, it's a right. Its left is D, which is his parent, its grandparent, and right is R, who is his parent. So I cannot touch it. And coming to the next element in pre-order, it is the end. As the pre-order ends, the construction of binary trees also gets it. Okay, so this is pre-order, and using pre-order and in-order, constructing a binary tree. Similarly, you'll be given questions on post-order and in-order combination and to construct it. The same process you are going to do, but only change is we all know that in post order, root is given the least preference, means it will be printed last. So kindly do the same process from right to left. Simple. In pre-order, the first element we consider from left to right we have traveled, and the first element we have taken it as root. Coming to post order, we are going to travel from right to left, and we are going to take the rightmost element as the root. Here 1 is the root. Identify where 1 is in an order. In order will be working same as per your in your previous problem. That is, it is going to split the list into two halves, left subtree and right subtree. Okay, so even here post order is meant to identify the root, whereas in order and pre order are meant in order is meant to identify the left and right children. So 4, 8, 2, 5 are on the left, whereas 6, 3, 7 are on the right. Next element in your post order is 3. Then in your in order, who is the left of 3 is 6. The next element is 1. I cannot consider 1 because 1 is the parent of 3. I cannot touch it. So make only 6 as its left child and 7 as its right child. Next element in post order is 7. Coming to 7, its left element is 3, but 3 is already related to 7 as a parent, right? So I cannot touch it. Very good. Next element is 6. Next element is 6. Identify 6. So in order, the left of 6 is 1, which is his grandparent. Right of 6 is 3, who is his parent. I cannot touch it. Next is element 2. Trace the element in order. Here it is. Its left are 4 and 8. I can place them. I know now, I understand that 4 and 8 will be in the left subtree of 2, but how precisely they are related, that is exactly who is his child, grandchild, I do not know. So right now I have placed them as the family of 2, and on the right side you can see 5. I cannot touch 1 because 1 is the parent of 2. Okay, very good. Next element under consideration is 5. So when I trace 5 in order, its left child is 2. 2 is the parent of 5. I cannot touch. 1 is grandparent of 5. Even that I cannot touch. So it makes 5 to be a leaf node. Next element is 4. I can clearly see that in order, I do not have any left element for 4. Right element is 8. I cannot consider 2 because 2 is the parent of 4. Right? Next element in post order is 8. Good. 8 do not have any children. Why? Because its left is 4, which is his parent. Right is 2, his grandparent. I cannot touch them. Okay, and next element in post, there is no other element. This is the end of the post order. So there ends the story. This is the binary tree for the given in order and post order. Yes, at every point of time, you can do reverse engineering and do that. So close in order and post order with the binary tree in your hands. Write the in order and post order and cross check with your question. Reverse engineering. The same with in order and pre-order also. Whatever the resultant binary tree you get, just close the question and write the in order and pre-order. Cross check with the question. You will find it out. Okay, that is rather than one evaluating yours, you can evaluate your own answer. Right? So many questions. This is the most prominently used questions, ma'am. N number of questions are there in the question bank. Please practice. Next one is graphs. This is another non-linear data structures which you have to learn. Okay, so what it says is it is a non-empty set of vertices as well as edges. So they'll be broadly classified into two categories, undirected and directed graphs. So guys, whenever they ask you about a graph, please mention that it is a non-linear data structure, and with a small diagram, please convey your point. If A, B, C, D, E are the vertices of this graph, it is an undirected graph. Why? Because if I claim that AB is an edge, then even I can say that BA is also an edge, right? So please do mention that. If I put arrows, right? Now this it gets converted into a directed graph where I can clearly say that AB is an edge, whereas BA is not an edge of this graph, right? So that is the basic difference between undirected and directed graphs here. Then comes weighted graphs. So we do have weighted and unweighted graphs also. The graph which you have previously seen is unweighted one. Weighted money between two vertices, the edge which they share can bear a weight. For example, if you look at maps, you can say that the distance between two cities is nothing but a weight, right? So, on a broader sense, you can say that you can have a directed weighted graph or unweighted graph, and you can have undirected weighted graph or undirected unweighted graph. Totally four types you can have. Okay, then guys, one of the important point is path. What is a path? Path is nothing but a collection of edges between source and destination. For example, Seattle is your source and Dallas your is destination. The path can be via Chicago, or via Salt Lake, or via San Francisco. These are the three different paths. Or you can have go to Salt Lake, Chicago, and then Dallas. Even that is a path. So the collection of edges is nothing but a path between the source and destination. Okay, then DAG, one of the important questions in your exam. DAG full form is directed acyclic graphs. Directed, the word itself tells you that they are directed in nature, and acyclic, cycles will not be there, right? So if you start from a node, you cannot reach that node or you do not share an edge or a path to reach the same node. Is nothing but a DAG. Okay, so the graphs can be represented using arrays as well as linked list. If you want to work with arrays, you need to use two-dimensional arrays. So have a look at undirected graph which I have given, and it's a adjacency matrix. We call the graph representations using adjacencies. Adjacency means based upon their neighbors. Okay, in undirected graphs, the neighbors as this graph do not have any loop. Loop money an edge from to itself. An edge to its if it starts with the two, it's the other end is also two. Such an edge is known as a loop. As loop is not there, all its diagonal elements are zero. You can see, and as it is an undirected, if there is an edge between 1 and 2, I can even claim that there is an edge between 2 and 1 also, right? So this gives me a symmetric matrix in case of undirected graphs, which is not the same in case of directed graphs. Because if there is an edge between 1 and 2, I cannot claim that it is also having an edge between 2 and 1. Okay, so it is not at all symmetric in nature. Coming to directeds, you can fill the data with the weights on it. Okay, directed weighted graph this is. So you can fill the weight. As there is no loop, all the diagonal elements are zeros. But the remaining, if they do not share an edge, I have given it as infinite. That is, you can reach or you cannot reach. For example, let me say 1 to uh, 1 to 3, for example, say 1 to 3, I do not have a direct edge, but I have a path 35. So 1 to 3, I can in future replace with the 35 rather than saying that infinite you can never reach, right? But few will be the cases where you cannot reach. It will be forever infinite in nature. So to be on a safer side, I'll first, while constructing the adjacency matrix, I'll take it as it is infinite. I cannot reach, but later I can replace it. But the basic representation will be with infinite zone. Okay. So next, even using linked list also you can do. That is, if the matrix is sparse in nature, that is 50% of its cells are filled with zeros or infinity, there is no point in using that. So better go for linked list. Have a look at the undirected graph, unweighted graph which I have given. So you can see that in the matrix, 2D matrix, loads of zeros are there. It is sparse in nature. Clearly you can see that, right? So to overcome that, by the help of lists, you can represent. Okay, and even in a weighted one also you can represent, but the node size increases because you have to store the weight of the edge also. Its size increases. Okay, so this is a linked list representation of an of a weighted directed graph. Okay, so basic applications of graphs will be in Google Maps, Facebook's, or one of the important questions, guys. Basic applications, okay? So Facebook, it gives you friend suggestions. So friend suggestion algorithm is there. And the background code will be is written based upon graph theory only. Google Maps, obviously that itself shows you a big example of graphs, right? So in computer science, all the flow of computation, how computation goes on, how you get intermediate results, everything will be shown in terms of graphs. Okay. Coming to the graph traversal techniques, we can traverse through a graph using depth first or breadth first search. Okay, traversal. The first one is depth first. Remember, guys, algorithm is important in exam point of view, and they'll give you a graph to perform depth first. For depth first, we are going to use stacks. Okay, hub. So here is a stack, right? So let's traverse. Starting any node you can take. If they give you a node, well and good. If not, you can start with any random one. So I have taken, I've inserted that into the stack. Then my top gets incremented, and as I have visited it, I have marked in the output. Then out of its neighbors, unvisited neighbors, I'm very pretty much clear, guys. Please remember, unvisited neighbors I'm talking about. So the unvisited neighbors of A, R, B, and C, hop to one of the unvisited neighbors, say B. So as I am at B right now, that means I have visited it. So I am going to display it, and as well as I am going to insert it into the stack also. Now, who are all the unvisited neighbors of B, D, and E? A is all, even though A is a neighbor of B, it is already visited, so I'm not going to consider it. So unvisited neighbors of B are D and D. Choose one of them and hop. So I have hopped to D. The unvisited neighbors of D are E and F. Choose one. I have chosen E. Unvisited neighbors of E are C and F. Choose one. I have chosen F. Then unvisited neighbors of F. There are no unvisited neighbors. So pop F. We are going to pop when we are not able to find any unvisited neighbor. So as I have removed F, now top is pointed by E. Do I have any unvisited neighbor? Yes. C is there, insert it. Now, do you have any unvisited neighbor of C? No, pop it. So likewise, I will be popping all the elements. Means I have started with an empty stack and I'll end with an empty stack. Okay, so this is how I'm going to work on depth first search using a stack. Why I have used a stack is very simple, because I want to access or work with only the recently inserted one. Remaining elements are not of my concern. So Coming to breadth first search, it is a contrary to that, where it is going to use queues for its traversal. That is, insert the element at the rear end and delete the element at the front end. Have a look at the same example. Initially, the queue front and rear are pointing to -1, and I'm going to start with A. And as I've visited A, the unvisited neighbors of A are B and C. Insert them both and remove A. Right? So I have inserted B and C. Now front is pointing to B, rear is pointing to C. Now who are all the unvisited neighbors of B? That is the element pointed by the front, which is B. D and E. Insert both and remove B. Right? So now the front is pointing to C. Unvisited neighbors of C, no one is there, so remove it. Now front is pointing to D. So who are all the unvisited neighbors of D? F. Insert F, delete D. Then unvisited neighbors of the front, which is F, which is E, are none, delete it. Unvisited neighbors of F, no one, delete it. Okay, so once the queue is empty, the front and rear will get its default value -1. So we have started with an empty queue and we ended up with an empty queue, and this is the breadth-first traversal of a graph. So very important questions from graphs is how to represent a graph, that is using adjacency matrices or adjacency linked list. Okay, so if they precisely ask you what is the adjacency matrix and explain, take a simple example, say roughly 5 nodes. Please do not take 3 nodes of a triangle and don't explain that. It looks very awkward. So take minimum 5 to 6 nodes and explain that. Okay, if they precisely give you a matrix or a linked list, please confine yourself to that. But if they ask you representation of a graph, then please do explain both the methods. One is adjacency matrix and the other is adjacency lists. Okay. Coming to graphs, the traversal techniques, breadth and depth. If they ask you depth first search precisely, please write the algorithm. It is a simple 3-step algorithm, and say specifically, underline it and say that stacks are used for its implementation. Take a small example and explain. The same with breadth first also. Yes, this module is very easy, only if you pay a bit of attention and listen to the videos attentively. Okay, thank you. I hope this video was useful for you to address the answers in your exams. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.